In this video, we're going to discuss InfoDrainage and some of the new drainage tools in Civil 3D, specifically the ones available in 2026. My name is Hunter Sparks, and I will also be joined by my colleague AJ Shubai in this video. First, we'll start with the Safe Harbor statement. This presentation may contain forward-looking statements on features and functionalities. Please do not make any purchasing decisions based on these forward-looking statements. Roadmaps can change, and we won't be assigning any times or dates to any of these updates. First, we want to get the lay of the land of the drainage tools at Autodesk because there are many. You have standalone tools like InfoDrainage, which is purely a drainage design and analysis tool. You have InfraWorks, which includes some drainage features and functionalities. And then probably the one that people most relate with Autodesk is the tools within Civil 3D. This is everything from laying out your pipes to analyze gravity networks. In 2026, it now includes ponds, underground storage, and channels as objects in Civil 3D, as well as the ability to analyze your drainage system. The tools highlighted here are what has traditionally been HydroFlow, and then I put the asterisk next to SSA, or Storm and Sanitary Analysis, because it is no longer automatically downloaded with Civil 3D. You need to go back and download it, and the latest version was 2024. Now, the two tools that we're primarily going to focus on today are InfoDrainage and then the drainage tools in Civil 3D, specifically the new ones that came with 2026. InfoDrainage is a full drainage design and analysis software. It is true to site, allowing you to exchange data back and forth between Civil 3D, allowing you to look at things like green infrastructure, sizing your pipes, sizing your ponds, generating your reports, etc. The drainage tools in Civil 3D allows you to analyze and design your drainage system, and allows you to run a cloud-based engine from InfoDrainage. So the tools offer you to run a quick analysis on your Civil 3D system. This can be your pipe networks, catchments, channels, stormwater controls, checking the capacity, checking for any flooding, but really about the system that lives within Civil 3D. And so there's been a lot of conversations with these tools coming out about what they are and what they aren't. So really what they are is it's not just one single function within Civil 3D. It is a set of tools in Civil 3D that allows you to analyze and check the capacity of your drainage system. And it does leverage the InfoDrainage engine. It allows you to incorporate ponds, underground storage, and channels in your drainage system. It does require the use of catchment objects in Civil 3D because that's really where you're going to generate your runoff. It's going to enter your system. It's a way to calculate HGL and EGL and apply it to the pipe networks. It allows you to export a summary report to Excel. Now, what it is not replacing InfoDrainage. InfoDrainage is going to continue to be developed. It is continue to be a standalone product that will have different features and functionalities. It is not an analysis tool which incorporates green infrastructure on top of just underground storages. So it doesn't have porous pavements, bioretentions, etc. It does not have 2D, it's not a 2D analysis tool. It doesn't allow you to run a coupled 1D, 2D simulation. It is not a tool that is set up to create customized drainage report outputs. You are choosing your columns, you're exporting to Excel where you can make those customizations. And it is not a tool for calculating composite parameters. Now that we've talked just at a baseline level of the tools, the next step is going to be showing you a typical drainage design workflow in each of the software. Now that we've discussed the different tools, I'm going to go ahead and walk through a workflow with the drainage tools within Civil 3D. In this model, we already have a pipe network, some catchments, and the top of pond drawn into our drawing. So the first thing we're going to look at is the catchments. As discussed, catchments are required in this workflow because it is where you're going to decide the runoff method and where the runoff is going to be generated and entered into the system to be used in the analysis. So under the catchments, you have general properties such as the runoff coefficient that you can assign, the area, the reference object, which is the structure where the runoff is going to enter the system. You can create your flow path, getting the lengths, and we also have a TR55 calculator. You can also put in user-defined time of concentration if you've calculated that outside of the system and just want to enter in that information. Under runoff, here's where you're going to select the runoff method. We have the time area, the SCS, the EPA swim, or the Santa Barbara. If I switch between these methods, you'll see that the properties that you enter under the runoff properties changes based on the method. For this example, we're just going to run the rational method. Now that we have a pipe network and catchments in here, we want to actually create a pond object. So this is one of the new features within 2026. You have these different drainage objects as far as a pond, a stormwater control, or a channel. So we're going to create a pond in this example, and we're going to do it from an object because we do have the top of pond right in the model as a polyline. We're going to give it a name. You can also give it a depth, as well as the side slopes, either the top or bottom elevation to begin. We're going to go ahead and give it to the bottom because that's where our pipes are going to go in and connect. And now we can see we have an actual pond object. If I were to click on the pond object, you'll see that we have some options to edit the geometry. If we want to take a square pond and turn it into a more rounded pond, or if we wanted to edit the fillets, we have that option to do so. We also have the option to add contours, run our drainage analysis directly from here. And we can also open the pond properties. Within the pond properties, we have the general information, the storage information where you can add the freeboard and look at the stage storage. We also have our inflows and outflows. So right now we have no pipes, channels, catchments, anything connecting to our pond, but we're going to go ahead and change that in the next step. And this can be a great place if you do have pipes connected to it to come and check to ensure that they are in fact connected. So now we have two places where pipes are going to connect into the system. So we can go ahead and get rid of the structures for the head walls because the ending of this network is now going to be the actual pond. And so we'll want to connect both of these into our pond and want to look for those crosshairs. And now it should be connected. And as mentioned before, one way to QA/QC is go to the pond properties, check the inflows, and ensure that the two pipes are connected. You could do the same for outflows if you had outflows out of your pond. So now that we have the different components that we need to run this model, we can go ahead to the Analyze tab and Analyze Drainage System, which is going to be a new button within Civil 3D. And this allows you to go into this analysis criteria where you can choose your rainfall. Right now, I have an IDF curve selected within this rainfall, but I can also open up the rainfall manager and see what rainfalls I have tied to this system. So I can set my return periods. I've already imported some NOAA Atlas 14 rainfall, but you can also import hydroflow or SSS IDF files. I can look at the depth or the intensity. And I can also add additional rainfall. So that was the IDF data, but I can also add distribution-based rainfall or known rainfall. Distribution-based rainfall can be really important for generating SCS curve distributions where you can give it a depth and a runtime duration, and you're going to be able to view the SCS distribution curve. And so now we can see using the 5 inches that we have that distribution in there. And so this is going to be listed as a draft until I save it. So we can go ahead and create and save that rainfall. Now, if we go back to the analysis criteria, you'll see that only the IDF is listed. That's because the rainfall that shows up in here is tied to the runoff method selected at the catchments. And so since we're doing rational method, the IDF curves are the only rainfall that applies. So now we're going to go ahead and run our analysis and look at the results. And now that the analysis is done, we can go ahead and get an overview of the drainage system. We can switch between our different return periods and see the total inflow volume, max inflow. We can go into look at our individual catchments and connection structures, stormwater controls. As we can see, all of our pipes are currently surcharged right now. and they are all 12-inch diameter. So this is where it shows that this tool is more of a straight analysis tool, testing the system that you have and not a pipe sizing calculator. It doesn't give you recommendations for your slopes, for your heights. So if I want to make changes to these to try and get out of the surcharged event, I can go ahead, manually swap parts, and then rerun my analysis, which is what we're going to do in the next step. We can also look at our stormwater controls and the information as far as the HGLs, max inflow, percent available based on our storm. So right now, all of our pipes and our structures are surcharged, and it looks like our pond might be oversized depending on if we are allowed to overflow in the 100-year event. So we can go ahead and make some changes to try and uh, clean up some of this information. Now, if we are done with this analysis, we can go ahead and apply these values to our pipe network, and we can also export the data. So if I were to go to the export data, we can give it the folder name, the location where we want it to live, as well as the choosing which return periods and what exported data we want to follow through. So here there is not a ton of customizations from a reporting standpoint, but you can push all of this information to Excel where you can go ahead, open up those reports, and if you do want to make some additional customizations, you have the ability to do that within Excel. So because we choose the entire analysis criteria and the different inputs as well as the results, all of those are going to be individual tabs within this document, and you'll see it shows a lot of the same information that we saw within Civil 3D. Now, if we wanted to iterate on this design to fix some of that information as far as surcharges and stormwater controls, we can go ahead and go back to our network and we can start upsizing some pipes. We could change some slopes and inverts within our pipes as well to try and mitigate some of the surcharging events so that we can get a more dialed in analysis. So I am just going to swap some of these parts and change the part sizes. And you're going to want to make sure, because I changed this pipe size, you're going to want to make sure that it is still in fact connected. So we'll just reconnect this information. And since our pond was a little bit on the larger side, maybe we want to bring this in just a little bit. And then we can go to our pond and ensure that those connections are still have our two connections. And now we can go ahead and rerun our analysis. And now if we switch back over to the connections, we can see we have some that are no longer surcharging, most likely the ones that we changed. Some of the structures are okay based on the changes that we made. So this is how you can get through that iterative process of your drainage design and use this as a checking system for your drainage system. And now if we get to our 100-year, we see that we're overflowing. Maybe that's okay, maybe that's not. So we might need to make some changes. We'll go ahead and assume that the analysis is now done and we want to push that value to the drainage system. So if you click apply values, now if I were to go to my pipe and look at the properties, we'll see that the HGLs and EGLs are actually within our pipe. And where this can be really beneficial is now if I go to my profile, I can change the pipe properties, the pipe styles in profile and actually turn on the HGL and EGL. And now those are shown within our system. So that's a workflow, how you can use some of the new drainage tools within Civil 3D. And now my colleague AJ is going to walk through the InfoDrainage side.
Thank you. Now it's my turn. I've imported the same model into InfoDrainage using the Export to InfoDrainage feature in Civil 3D. We have a video on that process. We'll be sure to link it in the description, but basically this model should look pretty familiar. You see we have our drainage areas, which are called inflows. We have our pipe network. We also have our ponds, and we brought in our surface as well. I can go ahead and turn off that surface and kind of clean up the view a little bit. We'll just kind of walk through everything that came in. If I click on one of these inflows, you'll see we've already got some runoff coefficients assigned. It's already got the time of concentration assigned. If I want to edit any of these, I can just double click on it and then edit that property right here in the plan view. Also, you'll notice if I hit this icon right here, it'll bring open a list of kind of preset C values. So if I don't have any assumptions, I can just pull one out of here. Or if I wanted to mass edit these, I would just come up to the build ribbon, find the column, and find the change I want to make. I can do it just like this, hit equal, and there we go. Also notice we can mass edit all of our junctions, connections, and stormwater controls using the same methodology. The next thing we're going to do is go ahead and get those ponds in here. There's a couple of different ways to do that. So if you look down here, you see I've already imported some CAD data as a background layer. And I have the outlines for the pond. If I zoom in here, you can see that outline. Now, option one, I could go ahead and either trace that outline and build a pond from scratch using the build function. Or option two, I can just right click and convert this background layer into a stormwater control or a pond already. Another tool I can use is the deluge feature. So if I come up here to preliminary sizing and hit deluge, I can set some minimum standards or base level assumptions, and water will fall on my site and pool naturally as it does on the surface. If I come down here and go to my deluge, I hit my 2D analysis, and you can see where everything fell. If I zoom in, you can not only see where the water is traveling, but also where it's naturally pooling on my site. Now imagine if I had nothing, I just had a blank site sheet, I had a surface, and I wanted to kind of see where ponds could naturally form. I could use this deluge tool and kind of give me a good idea of where things are going to end up. Next, we're going to need to connect our system to our ponds. So we'll go ahead and go up to the build section, select add connection, and we're just going to use a pipe in this case. Go ahead and go to new, and now we've connected it to our pond. I can double check it's connected by double clicking on the pond. If I do that, you see we now have an inlet. Also, if I wanted to edit anything in my pond, I can go ahead and do that here. I can adjust the area, or if I wanted to design based off of my volume instead, I could do that. You notice I can also set my freeboard, my starting levels, any other base assumptions that I want. I won't linger here too long because we do already have a video on pond sizing and also a training module on the subject. But if I hit this sizing calculator right here in my pond dialog, it'll open up this option right here. And so if I didn't have a footprint of the pond, but I did have a volume that I was going to try and capture, I could go ahead and use that as a design parameter for my initial design. But in this case, I already have an outline and initial size assumption, so I can just roll with that instead. All right, next I need to get some rainfall into my system. So if I go to rainfall, I'll select SES. And if I needed to generate a rainfall, I would just hit generate, and it would open up my NOAA Atlas, and I can navigate to wherever I need to go to and make sure I can get the correct standards. In my case, I already have a storm built out, so if I'll go to Rainfall Manager, I've already imported it, but this is where you would import it. And it's got some local standards for me to use, and I can adjust my depth and my time and select what storms I want to include in my simulation. All right, next up I'm going to go ahead and generate some flow paths. So I can click down here. I'll clean up my view real fast just so I can see my pipes a little better. So I click on Add New. I'm going to start upstream and then click on my most downstream point, and it'll automatically create a flow path. If I right click, go to show profile, I can see my pipe profile, and I can see that I need to clean some stuff up. If I double click on one of these pipes, it'll open up everything in a table for me. And then I can go ahead and do the same process and get all the other flow paths in my system out. That way I can quickly reference them. All right, next if we go up to preliminary sizing, we'll hit our network design wizard, and that'll open up this dialog. Now here we can go ahead and preliminary size one of the flow paths we created earlier. If I didn't do that, I could go to add path and just go ahead and do that process that I did earlier. Now again, InfoDrainage is a design tool, so even if I didn't have any pipe sizes or inverts, I can still run my wizard and get everything automatically sized out. We'll go ahead and go to next. And then here is where we select our storm for our design criteria. We've already done this earlier, so I can just double check that all my return periods are there. I have the right duration, I have the right area, everything looks good to me. Here's where we could input our pipe size library if we had one. I have a number of different options I could go through. I could lock some slopes. I can have the design wizard minimize excavation versus minimizing my pipe sizes if I was trying to play with my slope. You see, I've already imported a library, but if I didn't have one and I needed to build one out, I could do so pretty easily by using these options here. Then we also have some criteria to set max and min slopes. And then off to the right, we have check velocities. We can limit our pipe full conditions, flow constrictions, anything like that. And then here's the dialog where it tells us what all it's changed. You also notice we have a few warnings, nothing big to look at, but if it couldn't solve for anything based on our design standards, it'll give us a warning. So in some of these, we have to go back and manually adjust the slope or inverts to satisfy our standards. If I open up a profile, we should see what's going on. Now earlier when we imported our flow path in our design wizard, we had the ability to lock slopes or lock inverts on certain pipes. See here, we're dealing with some hilly terrain. So what I could do is go back and lock some of those pipes in their place, rerun my wizard, and then all the other pipes would adjust around my locked pipes, and I could attempt to smooth this out a little more. So some iteration is needed sometimes, but it's super easy just to rerun the design wizard and let InfoDrainage kind of take that work off your hands. Now again, friendly reminder, even if I didn't have any inverts, I didn't have any diameters, I had nothing but an alignment, I could still run this design wizard and have InfoDrainage design everything for me using my preferred standards. Now that everything's been sized, we're good to go ahead and validate our model. So we'll go ahead and validate. And here we're okay, but if I had an inflow that wasn't properly connected, or if I had a pipe diameter that was invalid or anything like that, it would give me a warning and I could find it and fix it. No warnings in this case, so we'll go ahead and hit go. And you see it sized everything up for me. Both my ponds are okay. It's telling me how much percentage I have remaining. The first pond looks pretty good to me. The second pond looks a little oversized, so I could go back to my pond and adjust the dimensions and then rerun my analysis and get it to a more efficient size. InfoDrainage is true to site, so any dimensional changes I make to my pond will appear as it would actually appear on the site plan, so we don't have to worry about it being too big or small. Here's our results tab. This is where we can see the results of our simulation. So we have a couple different things we can do up here. If we were running multiple phases, we could have a comparison report. We can run summary reports for pipes or manholes, or change which storm we're looking at if I had ran multiple ones. You notice there's also a manhole schedule that I could do, or I could print out all my profiles. What about if I wanted to make a custom report? InfoDrainage has a tool called flexible reporting. So if I come in here, I can click on connections, let's say, add whatever I want. But let's pretend I've worked with this client before. I know what kind of report they want. I know exactly how they like their things. I can either build that out manually, or I can load a template that I've used before. And this is based off of a report that a client's used in a drainage analysis. So while my colleague earlier is now stuck filling this spreadsheet out manually, mine's already filled out exactly how my client wants it, and I'm ready to hit print and get everything printed out. An additional little tidbit for you, if I go to hard copy headings, you'll notice I can set headings. I can add additional info to my report, or I could either add my or my client's logo if I wanted to. Flex reporting also updates automatically, so if I find an error or I rerun something and I have to re-update all my information, Flex reporting will do that automatically. I don't have to manually re-enter anything. Now up in the export tab is where I can get all my information out of here. If I wanted to export my pipes or manholes to GIS, I could, or to some text files, or if I had another model I wanted to run, this is where I do it. If I'm ready to get these changes back into Civil 3D so I can get my plans made up, I can hit this little guy up here. Again, check out that video that we put out on Civil 3D round tripping. However, as of the recording of this video, any changes I made to my ponds won't be re-exported. So if I came in here and resized the pond to make it more efficient, I would then have to take that design info back to Civil 3D and manually do it. But referring back to the safe harbor statement earlier, if you look at InfoDrainage's product roadmap, you'll see that pond round tripping is on the horizon for us. So what that means is that I'll be able to import pond objects from Civil 3D, make changes in InfoDrainage, and then export those changes directly back to Civil 3D. So be on the lookout for that. For the sake of time, I can't go over everything, but I'll go over some additional things real fast. InfoDrainage has the ability to do phase management. So let's say this was my existing analysis and I wanted to add a proposed phase. This is where I could do it, or even multiple phases of a development. I can make those phases without it messing with my original model. If I wanted to make my pond like cellular storage or bioretention, I have that ability as well, or even a tank. Let's say I got some new phasing and I needed to add some land uses for roads or green spaces or anything like that. This is where I could do that. Additionally, if I wanted to change some of my building footprints and add green roofs, I could do that. Or if I wanted to do some pollutant or first flush analysis, I could do that as well. InfoDrainage has a wide variety of inlet, outlet, and green infrastructure methods that I can use in my analysis, and I encourage you to research that and find what works best for you in your workflow. One last thing before I let you go, we'll recap some of those features that were used in our demonstration that are not available in Civil 3D. I'll leave it to you to read through everything, but my favorites and where I see the most value as a modeler are the Deluge tool, the Pipe Design Wizard, and of course the Flex reporting. Anything that'll save me from having to fill out spreadsheets is such a time saver. So don't hesitate to reach out to us and be sure to explore our YouTube channel for more tutorials. But with that, hasta luego, and we will see you next time.